4, 3, 2, 1.
You're looking at a live view of Falcon 9 as it awaits its 2:42 a.m. Eastern Time liftoff from Space Launch Complex 40 at Cape Canaveral Space Force Station. Hello and welcome to the live webcast for our 27th Starlink mission. My name is Michael Andrews and I'm a supply chain supervisor here at SpaceX. It's still Saturday evening here at our SpaceX headquarters in Hawthorne, California, but it's just after 2:30 a.m. on Sunday, May 9th at the launch site in Florida. Tonight's launch will mark a record-breaking 10th flight of a single first-stage booster. SpaceX's first reuse of an orbital-class rocket was on the SES-10 mission way back in March 2017. We've certainly come a long way since then. In terms of our payload, Starlink is a satellite internet constellation designed and manufactured by us here at SpaceX that can provide a high-speed, low-latency internet to people living in remote and rural locations around the globe. To date, over 500,000 people have placed an order or put down a deposit for Starlink service, and with every launch, we get closer to connecting more people across the world. If you've been following Starlink's progress, you'll know that our Starlink beta service is now available in the United States, in Canada, the UK, Western Germany, and the South Island of New Zealand. And as of this week, we are excited to announce that we've expanded our coverage areas to include Austria and France. For those of you who speak French, you can now access starlink.com en français, vive la France. As we launch more satellites, install more ground stations, and continue to improve our networking software, our data speed, latency, and uptime will improve dramatically. In addition to being able to provide our customers with better service, with every Starlink launch, we get closer to our goal of near global coverage of the populated world. In terms of our mission, currently, we're at T-minus 9.5 minutes, and all systems are go for an on-time liftoff tonight. There are a few major milestones to watch out for during our launch. The first is stage separation. This is where the first and second stages separate from each other about 2.5 minutes after liftoff. After stage sep, the first stage will return back to Earth and attempt its record-breaking 10th landing on our drone ship called Just Read the Instructions. Now, while that's happening, our second stage will continue on its journey. In order to get our satellites to their intended orbit tonight, we have 2 coast phases, and we'll be igniting our Merlin vacuum engine twice, with the eventual deployment of our Starlink satellites occurring around T+1 hour 4 minutes. Currently, we're just under 9 minutes to liftoff, and all systems are go for an on-time liftoff this evening. With that being said, let's take a closer look at the rocket you see on your screen. Here's a live view of Falcon 9. It's our 2-stage liquid-fueled rocket. Falcon 9 is approximately 229 feet tall. That's slightly taller than a 21-story building. And like I mentioned earlier, we're flying today's booster for a record-breaking 10th time today. This particular first stage booster first flew on the Crew Demo 1 mission back in March of 2019, and has since supported 2 additional commercial launches and 6 other Starlink missions, not including the 7th one tonight. The bottom 2/3 of our vehicle is known as the first stage. You can see the soot markings left over from its previous 9 flights. The first stage accelerates the vehicle through the Earth's atmosphere into space with the help of 9 Merlin engines located at the base of the rocket. And like I said before, we're going to be attempting to recover that first stage for that 10th time on our drone ship you see pictured here. It's known as Just Read the Instructions. Going further up on our vehicle, you'll see a black carbon fiber interstage ring, and on top of that is that white Falcon 9 second stage, which has a single Merlin vacuum engine. We call it the MVAC engine. Once first and second stage separate at 2.5 minutes after liftoff, the MVAC engine will ignite and eventually carries the Starlink satellites into an elliptical orbit around the Earth. And at the very top, you'll notice the large nose cone at the very top of the rocket. This is called our fairing. That's where the stack of 60 brand new Starlink satellites is safely enclosed. The fairing protects the satellites from aerothermal heating, aerodynamic loads, and contamination during its ascent. Once we reach the vacuum of space, we'll jettison those 2 fairing halves as the second stage continues on its journey to orbit. And similar to our first stage, this fairing assembly is protecting our payload tonight previously flew on the GPS-3 Space Vehicle 4 mission, and we'll be attempting to retrieve each fairing half from the water using the recovery ship Sheila Bordelon. In terms of propellant loading, we began loading prop since T-minus 35 minutes, and it's still ongoing. We use a rocket-grade kerosene, known as RP1, as our fuel, and we use a super-chilled liquid oxygen, known as LOX, as our oxidizer, and when combined, they help power the Falcon 9. Currently, RP1 and LOX are nearly fully loaded on both stages, and LOX will continue to be topped off right until the final minutes of the countdown.
Stage 1 RP1 load is complete.
In terms of weather, the latest forecast is 80% favorable for liftoff, and weather conditions look good for booster recovery as well. With that, the vehicle, the satellites, the weather, and the range are all looking good for an on-time liftoff just a few minutes from now. But if for some reason we do not launch today, we have a backup launch opportunity available tomorrow, Monday morning at 2:21 a.m. Eastern Time. We're currently about 4 minutes from liftoff, and Falcon 9 is now moving into those final stages of the countdown. We're currently waiting for the next milestone. That's where the transporter erector, or the TE, will retract. That's the white painted structure right next to the vehicle. First, you'll see here, it's happening right now. Actually, the TE clamps have opened, and then the transporter erector will begin to retract away from the rocket ever so slightly, just a few degrees. You can see it happening right now, actually. And then it'll wait there for a few minutes, and then it'll move again at T-minus 0. Hydraulics are going to pull the TE farther away from Falcon 9 as it lifts off and helps create space for Falcon 9 to clear the pad. Think of the TE as kind of the umbilical cord to the rocket. It provides liquids, gases, electrical connections, all to the second stage, and also provides air conditioning to the payload fairing. In terms of propellant, the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Superchilled liquid oxygen is our propellant oxidizer, and that's what's creating those white clouds you see forming around Falcon 9 near the inner stage. That's because the warm, humid, ambient Floridian air causes the liquid oxygen to turn into gas upon contact. The first stage, prop loading, is ending right around now, and the second stage, prop loading, should end
Stage 1 LOX
at
load
T-minus
complete.
2 minutes. And we just heard call out that prop loading has completed on the first stage. The last big major milestone is T-minus 60 minutes. That's where we'll say that Falcon 9 is in startup mode. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. And just 2 seconds from liftoff, we begin to light the 9 Merlin 1D engines, and we're set for liftoff. The Starlink payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still 80% favorable, and the range has cleared the surrounding ground, water, and airspace. We're green for launch in just 2 minutes away. At this point in time, just under 2 minutes, LOX loading on the second stage is wrapping up.
Stage 2 LOX load complete.
We've just heard confirmation that LOX loading is complete on the second stage. You're going to start to see a larger accumulation of white clouds forming around the vehicle. That's totally normal at this point. That's because we've topped off the vehicle with liquid oxygen, and any excess there is going to vent and boil as it becomes exposed to the ambient air. This time, the first and second stages are beginning to pressurize for launch, and we're about 10 seconds away from that startup call out.
Falcon 9 is in startup.
We've heard that startup call out, and we're now waiting for that final go for launch call out from our launch director.
Falcon 9, Starlink, LDs go for launch.
We're ready to go. Falcon 9's ready to go. All systems are go for launch. Now let's listen into the terminal count and watch as Falcon 9 takes our 60 Starlink satellites into orbit on its 10th flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff. Let's go Falcon for number 10.
Vehicles pitching downrange.
Stage 1 chamber pressure is nominal.
All right, Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying yet again another stack of 60 Starlink satellites to orbit. Just moments ago, we throttled the engines down in preparation for Max Q. That's the point of maximum aerodynamic pressure, occurs right after we go supersonic. After this point, we're then able to throttle the engines back
supersonic.
up. That call is just about 10 seconds away.
Max Q.
We've successfully crossed the Max Q threshold. We're throttling our Merlin engines back up. As the atmosphere gets thinner and thinner, the stresses on the vehicle continue to diminish. And we're just about a minute away from 3 major events happening one after another. Main engine cutoff, known as MECO, stage separation, and second engine start 1. To explain the first one, MECO, this is where all 9 M1D engines shut off and they slow the vehicle down in preparation for stage sep. And that's where, once again, the first stage and second stage separate. Stage 1 makes its way back down to sea level for landing, and stage 2 continues its primary mission, along with the fact that the MVAC engine lights up and propels that second stage, along with the Starlink satellites to orbit.
Following a nominal trajectory.
We're 30 seconds away from those events. Falcon 9 continues to be on nominal trajectory. Our MVAC engine is starting to chill to prepare for that second engine start just about 20 seconds from now. Shortly after these 3 events, our fairing will deploy and expose the Starlink satellites to the vacuum of space.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
All good news so far. The 9 Merlin engines have shut down. Our first and second stages are heading their separate ways, and our MVAC engine has begun burning and will continue to do so for about the next 6 minutes.
Fairing separation confirmed.
We have confirmation, and you can see it there. The 2 fairing halves have jettisoned and are heading back down. As a reminder, this is the second flight for these fairing halves, and we'll be attempting to recover them once again via a wet recovery from the contracted recovery vessel Sheila Bordelon. Everything is nominal so far.
Both vehicles continue to follow nominal trajectories.
We're just about 4 minutes after liftoff. For those of you just joining us, we have a lot going on. On the right-hand side of your screen, you can see our second stage and its MVAC engine is burning, carrying 60 Starlink satellites to orbit. And on the other hand, we have our first stage beginning its 10th recovery attempt. As stage 2 continues to burn, as you see here, stage 1 is actually going to execute 2 separate burns in order to make its way back to Earth. The first of which is the entry burn. Just a little more than 2 minutes from now, 3 of those M1D engines will reignite. This helps slows the first stage down as it re-enters the upper part of the Earth's atmosphere and reduces the loads on the vehicle. After that burn starts, ends, and is confirmed successful, we get ready for our final burn, the landing burn. It's a single center engine burn that brings the vehicle speed down rapidly in order to land on the drone ship safely. And as a reminder, we can't stress it enough. Tonight marks the 10th flight for this particular first stage. This is a record for our Falcon 9 rocket's life cycle. This particular booster first debuted on our Crew Demo 1 mission just over a year ago. Now, reusability is critical to what we do at SpaceX. This fact that we can reuse our first stages, it allows us to refly the most expensive parts of the rocket, which in turn drives down the ultimate cost to space access. And although this is the 10th time for this rocket, we first reused the orbital class rocket on the SES-10 mission back in March of 2017. It just goes to show how far we've come since then. We're about a minute away from that entry burn beginning. That burn should last for about 20 seconds. Now we're about 30 seconds away from that first stage entry burn igniting. The center engine will ignite at first. 2 more engines will ignite shortly after that. The Merlins on this first stage are optimized to operate at sea level, and they achieve about 190,000 pounds of thrust apiece during ascent and descent. Just a few
Stage
seconds
1
away.
FTS has saved.
Few seconds away from the entry burn.
Stage 1, entry burn startup.
And you can see that plume is starting to expand as the other 2 engines begin to fire.
Stage 1, entry burn shutdown.
And there you go, the entry burn has successfully ended. And now we're just a little more than a minute and a half away from the
Both
final burn.
vehicles continue to follow nominal trajectories.
Now, for those of you who follow along with SpaceX, you know that the soot you see on a rocket indicates it's been flown before. Here's an explanation of how that soot forms and why that first stage is so dirty in this case. The rocket-grade kerosene, RP1, that powers Falcon 9 is carbon-based, and when you burn it, it creates soot. Now, as we approach the landing site, like you saw just now, that long entry burn slows the vehicle down, and since we come in engines first, the booster flies through its own plume and exhaust, which
Stage 1
deposits
is
soot on the
transonic.
rocket. And if you watch the feed, like you saw just there, you saw that soot starting to fly up and stick to the lens. And we're only about 20 seconds away from that landing burn starting, and also during that time, our 4 landing legs will deploy while that single engine is firing to help us safely land on Just Read the Instructions.
Stage 1, landing burn startup.
See it there, our landing burn's begun. Hopefully we get
Stage
continuous
2 is in
coverage.
terminal guidance.
And also our second engine will cut off shortly after this landing attempt.
Stage 1, landing leg deploy.
We have continuous views right there. This looked great.
Stage 2 FTS is saved.
And
Stage
there
1
you
landing
have it.
confirmed.
We have a confirmation of a successful 10th landing of this booster and the 83rd overall successful recovery of the Falcon 9 first stage. Very exciting. This booster gets to live again. In terms of the second stage, we're waiting for that second engine to cut off. That second engine has cut
Nominal
off.
orbit insertion.
And we have confirmation from the GNC team that we are now in a good parking orbit. Second stage is now going to coast in this orbit for the next 35 minutes or so. We'll leave you with 2 things. We're going to leave you with this animation showing you where you're at in this coast phase, along with some groovy space tunes. We'll see you back here around T plus 44 minutes for that second engine start 2 phase.
Acquisition of signal Newfoundland.
Welcome back to the live webcast of SpaceX's 27th Starlink mission. We'll catch you up to speed. We had an on-time liftoff at 2:42 a.m. Eastern Time, and tonight's first stage had a record-breaking successful 10th flight and successful 10th recovery. In terms of our second stage, everything is still looking good. We're on a nominal trajectory, and we're getting ready for the SES-2 event in a few seconds. It'll be very short compared to SES-1 in comparison, just 1 second long of our MBAC engine. And after that, we'll go back into a coast phase, but coasting's putting it lightly. The vehicle's currently traveling at about 7.7 kilometers per second. That's over 17,000 miles per hour, a very fast journey for our 60 Starlink satellites. We may not have video of this event coming up, but currently the vehicle's over the Indian Ocean, and we're going to wait for those call-outs just a few seconds from now. And then once this event is confirmed as being good, we'll wait to see if we have a good orbit before we continue our second coast phase before payload deploy. We're still waiting for confirmation of the second engine start and second engine cutoff, as well as confirmation of good orbit. But regardless, we are going into another coast phase. This one will be a little shorter. During this time, not only are we going to coast to the correct deployment point along the Earth, we're also going to spin the spacecraft along its central axis. This gives the Starlink satellites the natural momentum they need to space themselves out over time after they deploy. We'll check back in with you at about T+1 hour and 3 minutes. Good morning and welcome back once again to our broadcast for our 27th Starlink mission. One small note, shortly after we entered our current coast phase, we confirmed that our second engine start and shutoff was successful. We're currently in a good orbit awaiting payload deploy. But if you're just joining us, we'll quickly recap today's mission, starting off with a successful liftoff from Cape Canaveral Space Force Station at 2:42 a.m. Eastern Time. We then had successful stage separation. We recovered our first stage for the 10th time on our drone ship, and we had 2 successful second stage MBAC engine startups. Right now, we're coming up on deployment of our stack of 60 Starlink satellites. It's just about 30 seconds away, while our second stage is in between Australia and New Zealand. And you see it right there, actually. Those satellites are starting to slowly extend. And shortly after this, they're going to deploy their individual solar arrays. And over the next few days and weeks, they're going to distance themselves from each other and use their onboard ion thrusters to make their way to their specific operational orbits. And with that, that will bring our webcast to a close for today. We want to thank the Range and the Federal Aviation Administration for supporting today's mission. And thank you to you, all of our viewers, as well to all of our Starlink customers using our beta service at this time.
Nominal payload
If you're
insertion.
interested in being part of our beta program, please head over to starlink.com and sign up. I hope you enjoyed the webcast tonight, and a special thanks to all the mothers out there. Happy Mother's Day.